for the most part.
Okay. See any emails? I figured. Okay, what do we got?
So these are these first few problems are the directions are to transform each polar equation to an equation in rectangular coordinates.
Okay.
The first one is r equals 2.
Okay. So let's list our conversion factors over here. That's a big one. This is a big one. And x squared plus y squared equals r squared is a big one. So what can I do here? In other words, I want to start with this polar equation and end up with an equation that's got nothing but x's and y's in it. No thetas, no r's.
You can square both sides.
Okay, there you go. That's the answer. Because now I'll just substitute x squared plus y squared for r squared. There's your rectangular equation.
Okay. All right.
What else you got? We'll see if we can do one more problem before I call you.
Okay.
Do the audio gradually deteriorating.
Yeah, it's not sounding good right now.
I wonder what that is. That's baffling to me. I can't imagine what would cause the audio to gradually deteriorate.
This computer is
out great.
This computer is a little bit older, the one that I'm on, so the mic might just be kind of shot.
Well, you might try, I don't know if you ever done this or not, but try closing out everything else that's running besides GoToMeeting. GoToMeeting is a real hog of your random access memory. I'll notice that if I close out other things that I have running at the same time, even just other browser windows, that I will frequently get better reception on my GoToMeeting. I don't know. You can try it if you are running anything else, because that would definitely answer why it would happen. Because gradually, as you run GoToMeeting, your resources get used and get low, and then your audio gets affected.
All right.
All right.
Yeah, I just closed everything up. See if it's good.
Got an immediate. No, the audio's better.
All right.
That's going to be it. That's what's going on. Okay. What's the next polar equation?
Theta equals pi over 3.
All right. Let's see. X equals r cosine theta. My theory, huh? About the audio.
Yeah.
So, theta equals pi over 3. Thinking. So, I don't have an R. I know this is a straight line. In other words, I know that it graphs, it's a 60-degree angle and goes through the origin. So there's the graph of it. And what's the graph of this straight line? X equal Y equal X. Okay, so somehow we have to turn this into Y equal X. Well, let's see what happens if I do the following. If I do x equals r, cosine of 60 degrees is 1/2. Correct?
Correct.
And y would be equal to r times square root of 3 over 2, the sine of 60 degrees. So how can y be equal to x? That's the question. In other words, x is equal to 1/2 r, and y is equal to root 3 over 2 r. So how do we end up with x equal y, which doesn't appear, oh, maybe this doesn't go through the origin. No, it must not. In other words, this must not be the equation. Oops, sorry. Here I can back up. No, this is not right down here. And it tells me how I'm supposed to solve it. Because I've got these two things, and I want to eliminate r. Now, I'm going to let r equal 2x, correct? That.
Yes.
And the same r equals 2y divided by root 3. Therefore, that equals that. And there's our basic answer. It gives me 2x equals 2y over root 3. Or, let's see, the 2's will cancel. I end up with y equals root 3x. So there's my equation. What I had to do was evaluate the cosine and sine at this given theta, and then I had to eliminate r, because they didn't tell us what r was. Well, the way to eliminate r is to solve for it. The one thing I know about r is this r is the same as this r. I'm sorry, I point with my cursor and I forget you can't see it. This r is the same as this r. And once I've solved for r, then I can equate 2x to 2y over root 3.
Right.
I'm going to call you.
Okay.
Therapeutic it is to eliminate all that static. It really does. Can you hear me okay?
Yes, I can.
Yeah. It really does have a similar effect as if you're scratching your fingers against a chalkboard stopping.
It does, yeah.
Yeah. You may have to turn yours on telephone also. I don't know. Did you do that already?
I think I did.
Yeah.
Yes.
I think that otherwise there's feedback problems. All right. What's the next one?
R sine of theta equals 4.
Well, what's r sine of theta equal to?
Y.
So y equal 4 is the answer.
Oh, right. That's an equation.
Yeah. And there's no x because that's a horizontal line.
Right.
Okay? What else?
R cosecant of theta equals 8.
Okay. Let's turn this into a sine or a cosine. What is it?
Sine.
So it's r over sine theta equals 8. And now r equals 8 sine theta. And now notice that I got a little bit of a problem. my r is not times the sine theta. If it was, I could just substitute y for it. So what I have to do is that clever little technique I told you about last time where I multiply both sides by r, which gives me r squared there, and it puts an r in front of the sine theta, which is perfect. In other words, I know what that is. That's y. Also know what this is. That's x squared plus y squared. So my answer is that.
Alright.
Okay, and this is the one that, this is the only one I can think of, although I'll bet there's tons of them, where you really have to kind of think out of the box and come up with this creative way. In other words, here's the problem when we look at it, when it's like in this format here. And once I've gotten it to this, all my conversion factors are x equals r cosine of theta, y equals r sine of theta. I need that r in front of one of those, and it's not there. So I'll add it. I'll multiply both sides by r. Now I've got r sine of theta sitting pretty, where I can just substitute y for it.
Okay.
Okay?
Alright.
What else? I'm sure we're going to have to go the other way here soon. Converting XY equations into polar equations. But that's all right. Let's do a few more of these, because these take a little getting used to.
Yeah, r times secant of theta equals -4.
It's going to be a similar problem. Notice that the way to convert these is to try to get everything in terms of sines and cosines.
Right.
In other words, working with secants is tough. We don't have any of those conversion factors. All three of our conversion factors involve sine and cosine, or 2 out of the 3 do. So let's first convert that. What is the left side equal to?
R over cosine of theta.
Now we're going to multiply both sides by cosine of theta, and I'm going to get the similar situation that we had on the last problem. I'm looking at a cosine of theta, but no r. What's my next step?
Multiply both sides by r.
And now what's the last step?
X squared plus y squared equals 4x.
Correct. And that you can leave it like that. You don't need to bring everything over on one side.
Okay.
However, we can tell that that's a circle.
Right. Yeah.
No, or is it? No, I don't see any number is the problem. So if it's a circle, oh, but we'll end up with a number over there. Yeah, in other words, I'm going to do this, and then I'm going to have to complete the square on the x term, and when I complete the square, I'm going to balance it out over here, so I'll have a number. So that is the equation of a circle. In polar, that's the equation of a circle that's not at the origin. If you have a circle at the origin, then it's just r equals a number. So whenever you have an x squared and an x, well, by the time I complete the square, that's going to be x minus 2 quantity squared, which is a horizontal shift, so it's not at the origin. So when your circles are not at the origin, they take on these kind of forms in polar. They're not always just r equals a number. Okay, what else?
So these next ones are, the directions are plot each point given in polar coordinates.
Okay.
The first one is 3, 90 degrees.
Wow. My cursor's acting funny. I wonder why. Okay, well, I guess the best way to do it is just convert that polar to an xy coordinate. Although, do we need to? What's your task here? To graph it?
Yeah, just plot it on a polar graph.
We don't need to convert it. Where's this point go?
It just goes up 3 on the y-axis.
Exactly. In other words, the coordinates are 0, 3. Not that they ask for the coordinates, but in other words, we didn't need to switch it to graph it. Maybe a lot of these, maybe that's the point of this exercise. What's the next one?
-2, 135 degrees.
Okay. Yeah, we don't need to convert any of these. Do the theta first. Okay, so there's the 135 degree angle, right?
Yeah.
Now where's my point going to go?
2 units in the opposite direction.
Correct.
In the quadrant 4.
Right. Now the thing is that I know the length of that line is 2, but I don't know the coordinates of that point. Although it's not hard to figure out because that's a 45 degree angle. But they didn't ask for them, right?
Right.
I guess they didn't ask for them. In other words, I've got a point here that I graphed, but I don't know its coordinates. So maybe they do need the coordinates of the point. Well, the coordinates of this point got to be 2 or root. Let's see, if you've got your 45, 45, normally it's 1, 1, root 2. Well, this one is root 2, 2. So the coordinates of this point are positive root 2, negative root 2, just because it's in the 4th quadrant.
Okay.
So all I did was solve this triangle, knowing that that's 45 degrees.
Okay, right.
Okay. Whether you actually had to do it or not, I don't know. But I don't know how you would have graphed where the point was. Two units down on the line, maybe that's enough. I guess that, I don't know. No, not really, because usually an XY coordinate system, the only measurements you have are in a horizontal and a vertical direction. So it wouldn't really be possible for me to draw a line and say, go 2 units on that line. I don't know where 2 units are relative until I've solved for the X and Y coordinate. Now I can say, well, I got to go to the right root 2, and I got to go down root 2. And that allows me to plot that point right there. So in this case, I think you do actually have to solve for the X and Y coordinates. Maybe that's actually the easier way to do it. I kind of did it the tough way.
Okay.
Let's see. Let's just talk about that for a second. If if X equals R cosine of 135, that's relatively easy to figure. X equals minus 2 times negative root 2 over 2. Well, there's the X coordinate. And Y is equal to minus 2 times the sine of 135 degrees, which is positive root 2 over 2. So the Y coordinate is the negative root 2, and the X coordinate is positive root 2, which is exactly what we got. Actually, it was a little faster to do it this way. In other words, to convert the 2 points to XY first. Then you know exactly where it is, and we don't have to do that go in the opposite direction business.
Okay.
Although it's nice to know that. In other words, all we're doing is examining this problem from multiple perspectives, which is a good way to study math.
Okay.
You don't always just want to know one way to do a problem. A lot of times you want to, it's helpful to do them multiple ways.
Right.
What do we got for the next one?
So the next one, it gives the polar coordinates.
Okay.
And I need to find the rectangular coordinates.
Okay, we just did that, so we know that's a piece of cake.
4 comma 3 pi over 2.
Tell me what the x-coordinate is. Set it up first, and then we'll solve it. But
X equals R of 0. Right? So x equals 0.
well, you were doing 2 steps in one. My brain only works 1 step at a time. You're right. You're right. That is 0.
Yeah.
So x equals 0, which is a vertical line that is the y-axis. And if you think about this, if I were to try to graph it with polar, I'd go all the way down, and then I would go in the opposite direction, or the same direction, 4 units, which would put my point right there. Oh, I didn't figure out the y.
Oh.
Yeah, let's figure out the y. What's the y? It's 4 sine of 3 pi over 2. Well, I can see where the y is going to end up. What is the coordinate of it?
-4, right?
Yeah. In other words, if you had any question about what's the sine of 3 pi over 2, it's either got to be 0, 1, or -1, right?
Right.
Well, and looking at the picture, it's clearly not 0. It's clearly not 1. It's negative.
Right.
Okay.
Well, that's not bad.
No, using these conversion factors is the way to go so far on just about everything we've done. I think it's the quickest way, yeah.
So the next one is 6 comma 150 degrees.
Okay, what's the x-coordinate? Spell it out and then solve it. That's the way to do these. 6 times what?
6 times cosine of 150.
That's what I mean by spelling it out. And now solve it.
It's 1/2, right?
No.
-1/2.
So the equivalent of 30 is root 3 over 2. That is...
Oh, I'm sorry. Yeah. I was at the wrong angle.
And that's negative root 3 over 2 because it's second quadrant.
Right.
So it's 6 times negative root 3 over 2, which gives you negative 3 root 3. So that's the x-coordinate. What's the y-coordinate? Spell it out. Or
Yes, y equals 6 times sine of 150 degrees.
okay,
So it's 6 times 1/2.
that's the answer.
So y equals 2.
Yeah, because we know that's in the second quadrant, sine is positive.
So negative 3 root 3 comma 3.
Right.
All right.
Yeah, these conversion factors, boy, 90% of these problems, the only 2 conversion factors you need are the x and the y. This one that's r squared equals x squared plus y squared, we rarely need that.
Yeah.
There is one other thing that you have to know, and that's this one. And this is the trickiest one. Let's just talk about it while I got it up here. Sometimes this program makes me want to rip my hair out, which is hard because I don't have any hair. So it's equal to the inverse tan of y over x if x is positive. It's equal to the inverse tan of y over x plus pi if x is negative.
Okay.
And
if
it actually can be equal to 0. If x is equal to 0, then we're dealing either with a 90-degree angle or a minus 90-degree angle, one or the other.
Right.
And that would depend on what y is.
Right.
If y is positive, you're dealing with a 90-degree angle. If y is negative, you're dealing with a minus 90-degree angle. So let's put that in there. If x is equal to 0, the problem is it gets so complicated now. And y is greater than 0, it's 90 degrees. If y is less than 0, then it's minus 90 degrees. So that's why none of your books have this part. I've never seen a book give what happens when x is 0.
Right.
I still find it very interesting that the calculators won't do it. They won't do inverse tan of a number divided by 0, and yet they should be able to do it.
Huh.
I guess when they see that division by 0, they go, screws up everything.
Yeah, that's weird.
All right, so what else?
So the next one is negative 2 comma 2 pi over 3.
These are all pretty easy going this direction. The only ones that involve that theta are when you're going the other direction. When you're going from rectangular to polar, the first thing you got to do is figure out theta, and then you have to use that inverse tan thing. Okay, in this direction, the only thing you ever have to use are these two conversion factors. So, what's x? Just plug in for the moment.
X is negative 2. Negative 2 cosine of 2 pi over 3.
Now let's solve that. Cosine of 2 pi over 3.
That's, we just said it's negative 1/2.
Well, the cosine is negative 1/2. The whole thing is negative 1. Because the 2's cancel. It's positive 1.
Positive 1.
Yeah. Here, let me do this correctly, geez. I can't tell you how many times I've yelled at students for dropping negative signs. And I just did it. It's so easy to drop one. And everybody does it. Everybody. I guess they think that, boy, if there's a bunch of negative signs, I'll just say it once, and it's got to be the same thing.
Right.
But that's a positive 1. And what's the y coordinate?
Negative root 3.
Because that's positive in the second quadrant. Okay.
Right.
All right, what else?
All right. Now, got complex numbers.
Okay.
In the complex plane, and I need to write them in polar form.
Okay.
The first one is negative 1 plus I.
I may have to open my book. It's been a while since I've done this. You're wanting them, I know how to do this. Hold on a second, but it'll help if I'm reminded. Yeah, this is where you start to get into De Moivre's theorem also. Whether you'll get into that or not, I don't know, but hold on a second. Let me find where this is in my book. Polar coordinates and complex. I think this, yeah, this has got to be right here. Here we go. The trigonometric form of a complex number is what we want. If z equals a plus bi, which is standard complex number format, then z is also equal to r times the cosine of theta plus I sine of theta. So what do we got here? We got minus 1 plus I, that's our z, equals r cosine of theta plus I sine of theta. We got to figure out what theta is. Hold on a second, just a second. We're trying to put this complex number into polar, so we need to solve for r and theta. Alright, they got an example here. Let's see, what do they do? Okay. So first of all, r is another. R is equal to the modulus of the two coefficients. Yeah. Are you familiar with this term modular? It looks like absolute value, but it doesn't really mean absolute value. Whoops. Let me put r's in here.
No, I don't think so.
It's the magnitude of that complex number, and the magnitude is the square root of a squared plus b squared. So it's really the square root of a squared plus b squared. In other words, the coefficient, the real number, b is the coefficient of the imaginary number. With me?
Yeah.
So r, in our case, is the square root of 1 plus 1. Excuse me? Yeah, because I'm squaring a negative 1, which makes it a positive 1, and the I has a coefficient of 1 already. So r equals the square root of 2. Just a second. Now figuring out theta. Because the reference angle for theta is minus pi over 3. Hold on. I'll be with you in a second. I just got to figure out this.
Yeah, not a problem.
Reference angle. Just a second. How are they getting this? Now let me do the one I'm working on, and maybe you can assist here, and then we'll do yours. Here's the number they're converting to this format. Okay? And the first thing they do is figure out R. Well, R is the square root of a squared plus b squared. So I got R is the square root of 2. So I know that my function is this is so staring me in the face, I can't see it. 1 minus square root of 3, I figure out R, that's 2. Excuse me. It's not 2. It's 4. I mean, it's square root of 4. Well, that's okay. Yeah, that was just a minor error. So R is 2. Now it says because the reference angle for theta is minus pi over 3, then theta is equal to minus pi over 3, or 5 pi over 3. Now, how did they come up with the reference angle as pi over 3 from this? Theta is the inverse tan of x over y over x I guess that's the y and that's the x. So I get theta equals the inverse tan of minus root 3 over 1. And that is a 60-degree angle. That's negative, which means it's minus pi over 3. Yeah, that's what they do. In other words, the y is b and the x is the real number. You see where I got my y and my x from here?
Yeah.
In other words, that's b, that's a, and now I can solve for it, and I'm going to use the same technique. Or can I? Let's see. In this case, x is positive, so I would not add pi to it, and that would be my answer. And now I can write the polar. In other words, r, or really 1 minus, that's z, that's my complex number, is equal to 2 times the cosine of minus pi over 3 plus I times the sine of minus pi over 3. Now I just have to put in numbers for that. Cosine of minus pi over 3, it's positive 1/2 plus I sine of minus pi over 3, that's negative root 3 over 2. And there is the answer. Oh, interesting. They left, in my book, they didn't solve for those. They left it like this. That's their answer. That's the trigonometric function of a complex number. That is the trigonometric form of a complex number. In other words, they didn't figure out that that was 1/2 and write this at the bottom. I guess eventually you'd have to, though. I mean, if you really wanted the number, wouldn't it have to be, notice what I get. I get 1 plus root 3 I. That's why they don't take it down any further, is because you get back to your complex number. In other words, this up here is a true statement. I've got my complex number on the left, which is z, and z is equal to this. And so this complex number turns into this trigonometric polar format. And then if I do solve for it, I end up with my complex number again. 1 minus root 3i, although it was a plus, not a minus. No, it was a minus. Ah, this is a minus also. That minus right there. In other words, if I do solve it all the way out, I just get the complex number equals the complex number. And that's why they don't. Okay, so now let's do your problem. What was your problem now that I know how to do it?
Negative 1 plus I.
All right, negative 1 plus I. So first of all, let's figure out r. R is the square root of a squared plus b squared. So that's 1 plus 1. So r is the root 2. Figured out how I do that?
Yeah.
Okay. Now theta. Theta is the inverse tan of what? B over A. Instead of y over x. Because technically that's not y. The coefficient of the I term, which is b, that's what we're doing, is b over A plus pi if A is less than 0, which it is in this case. So theta equals the inverse tan of 1 over minus 1 plus pi. Now what is that? What's the inverse tan of minus 1?
Negative pi over 3.
Pi over 4. The tan of 45 degrees is 1. Therefore, the inverse tan of minus 1 is minus 45 degrees. So it's minus 45 degrees plus pi, or I could say minus pi over 4 plus pi, which gives me 3 pi over 4. So there's theta.
Okay.
So now, how can I write this complex number in trig format?
Root 2 times cosine of 3 pi over 4 plus I times the sine of 3 pi over 4.
Perfect.
And that's
That's your whole answer. In other words, if I did any more work, if I figured out what cosine of 3 pi over 4 is, I just get back to this.
Right.
So I haven't really given it to you in trig polar format if I don't give it to you that way.
Right.
It just comes back to a complex number. So yeah, this, as odd as this looks for a final answer, because you could simplify it, but you don't. You don't want to. Okay, do you have another one? Or if you don't have another one, make sure you understand every step I went through here.
All right, I've got one more.
Okay, good.
A little more confusing.
Okay.
It says negative 2.
Okay. So R is equal.
A is negative 2 and a B is 0.
Correct.
Right?
Yes. So it's plus 0i, if you like. That's a better way to think about it. In fact, that's the best way, the only way to think about it. So what's R?
2.
Okay. What's theta? fill it in, we'll figure it out later. In other words, it's b over a, right?
Right.
So it's 0 over minus 2 plus pi because the denominator is negative.
Right.
Okay, so let's figure out what the tangent of this is. Tangent of 0 is 0. In other words,
Oh, right, yeah.
that's 0 no matter what. I'm not dividing by 0, I'm dividing into 0. So that's 0 plus pi, which means the answer is pi for theta. Now my minus 2 plus 0I in trigonometric format is what? Actually, it's not trigonometric format. Yeah, it is. It's trigonometric form of a complex number is what it's called.
2 times cosine of theta, I mean of pi.
These are in parentheses. I noticed last time you left off the parentheses, and it actually does matter. In other words, everything else that follows is in parentheses, like that. That 2 multiplies both terms.
Right.
Okay, so it's cosine of what?
Of pi plus I times the sine of pi.
Right. And notice the sine of pi is 0, and so your I term goes away. Cosine of pi is negative 1. So you can always kind of test to see whether you have it right by going ahead and solving it and make sure you get the same thing you started with. Even though this is the answer, if my life depended on that being the answer, I'd want to go ahead and check out those numbers and make sure that I end up with that. And I do. Cosine of pi is negative 1. So. Okay.
Okay, so the next problem is the reverse.
Okay.
So it's 3 times cosine of 210 degrees plus I times sine of 210 degrees.
All right, we got to come up with the complex number. So theta is clearly 210 oh boy, of course they don't have an example of one of these. We don't need it. Let's figure it out. Let's see. Theta is 210, which looks like 30 degrees plus pi. So my y, so let's see, if the inverse tan of b over a has plus pi equals 210, then the inverse tan of b over a equals 30.
Okay.
And that is 1 over root 3. In other words, b could be, if I had the inverse tan of 1 over root 3, that's 30 degrees. In other words, the tan of 30 degrees is equal to 1 over root 3. Therefore, the inverse tan of 1 over root 3 is 30 degrees. So from this, can I assume that my b is 1 and my a is root 3? I don't think so. I think I have to have an a that's negative. In other words, here's what I'm going to say. Here's what I think the answer is.
Okay.
Let's see if that's correct. In other words, is that true? Well, what's cosine of 210?
Negative root 3 over 2.
What's the sine of 210?
Negative 1/2.
I'm going to multiply everything by 3, so I do not get that. Ah! But it told me how to get the answer. I knew it's all I had to do was fool around a little bit. This is the answer. I don't have to do anything else. If they gave me the trigonometric format, is all I got to do is solve for cosine of 210 and sine of 210 and then distribute everything. So here's my answer. Negative 3 root 3 over 2 plus, or minus, excuse me, because it's minus 1/2, multiply the 3 minus 3/2 I. In other words, the solution comes from just simplifying this thing, the very top thing. Remember when we were going the other way, this would be our answer, and to verify it, we would solve it and make sure we got what we started with. Well, if we want to know what we started with, just solve it. That does it instantly.
Okay.
In other words, what I have in the rectangle is what I get when I simplify that trigonometric form of a complex number. And now I have it in A plus BI format. Got another one where you got to go that way? Let's do it real quick. We got 2 minutes. I actually got 7 minutes. I was 5 minutes late. I just remembered.
Next one is 2 times the cosine of 5 pi over 6 plus I times the sine of 5 pi over 6.
Okay, what's the first step?
Find the cosine and sine of 5 pi over 6.
Let's see, that is second quadrant, same as pi over 6, which is 30 degrees. So what is it? Negative root 3 over 2. Because it's second quadrant. Okay.
Okay.
Now what's sine of 5 pi over 6?
Positive 1/2.
Okay, so it's 1/2 times I. Now distribute the 2. What do you get?
Negative root 3 plus I.
There you go. It's much easier to do this, right? I mean, there's really nothing to know here. The only thing to know is how to figure out these cosine and sines of that angle. But there's nothing else involved. Yeah, there's nothing else involved. It simplifies straight down to the complex number in A plus BI format. Yeah, it's only slightly difficult going the other way. And even that, as long as you remember how to solve for theta, and if you remember that x and y are the equivalent of A and B.
Right.
Yeah, it's not super easy to solve for theta. Although, yes, it is. Yeah, it is. As long as you say inverse tan of B over A plus pi of A is negative. If A is positive, there's no plus pi added to it. Do you have any other types of problems that we could do in 5 minutes?
Yeah,
Let's try one.
we can do some practice solving triangles. Get
Okay.
some of those.
Okay. Let's do it. I assume they're going to give you 3 pieces of information, right?
Yeah.
So give me the 3 pieces of information.
So the first one is B equals 4, C equals 1, and alpha equals 120 degrees.
Immediately, we know that this is not the ambiguous case. First of all, it's side angle side,
Right.
which is never the ambiguous case. So how are we going to solve, what are we going to use to solve it? Law of sines or law of cosines?
Law of cosine.
Correct. There's only two situations where you use law of cosines to start. And that's those two. Side angle side or side side side. With either of those triangles, start with the law of cosines. You always finish with the law of sines. In other words, there is no problem. There is no problem where you solve it entirely with the law of cosines. So what is the law of cosines with regards to this situation? There's actually three laws of cosines, but the one thing we know for sure is that it's the cosine of 120 degrees, right?
Right.
So what goes on the left side of this equation? A, B, or C, and little or capital? Little a. In other words, whatever that angle is, which was capital A, the thing that goes on the left side of the equation is little a. Okay? And then I've got what goes in the middle is b squared, that's a squared, excuse me, equals b squared plus c squared minus b times c times cosine of 120. You with me?
Yeah.
Okay, now we just need to fill in everything. So a squared equals 16 plus 1 minus 4. What's cosine of 120?
It is -1/2.
So what we have here is a squared equals 17 plus 2 equals 19. A equals root 19. Now, you clear on all of that?
Yeah, all good.
Okay. I just wanted to know before I erase it. And we'll draw our triangle because we still have to solve for a couple things. We've still got two angles missing.
Right.
Okay, so A, I'm going to draw it like this. This is A, I'll call that B, I'll call that C. This is little b 4, that's little c 1, little a is root 19, and that's 120 degrees. So, what should I solve for next, and how?
Solve for angle C.
Okay, how?
The sine of 120 over root 19 equals the sine of angle C over 1.
Okay. So we've got this, going down here, we got the sine of C equals root 3 over 2 root 19. Correct? Did I do that right?
Yes.
Okay. So C is the inverse sine of that number. Go ahead and find the inverse sine of that number. In degrees. The one time you want your calculator in degrees is when you're solving triangles.
11.5 degrees.
Now, so we use the law of cosines to solve for that. We use the law of sines to solve for one second angle. And then we don't need to use the law of sines to solve for B. We can just use the fact that triangles have 180 degrees in them.
Right.
So that's 131 and a half. That must be 48.5. And it's fully solved now. Also shows you another good reason why you shouldn't waste time rationalizing stuff.
Right.
Notice that we could have spent a lot of time rationalizing that. When we write it like this, that's not hardly rationalized, but we never really had to rationalize it. You put all that into a calculator to get the angle, and the angle is what we were solving for. So we never had to give out an answer that had an irrational denominator.
Right.
All right, why don't we call that a session?
Okay, thank you very much, Mr.
You're welcome, William. I will talk to you next time.
All right, have a good night.
You too.